Hello everyone, I am Aditya Gupta and I am a SC Mathematics student in IIT Gandhinagar. In this video, we are going to learn Rolle's theorem and mean value theorem. So we will start with Rolle's theorem and then use it to prove mean value theorem, and we will also see the geometrical meaning of Rolle's theorem and mean value theorem, and finally we will solve an example using mean value theorem. So let us start. So Rolle's theorem. Suppose f is continuous in, suppose f is continuous on closed interval a comma b and differentiable in open interval a comma b, differentiable in open interval a comma b with f of a equals to f of b, with f of a equals to f of b, then there exists at least one point c in open interval a comma b such that f is equals to 0. So let us see this statement. Suppose f is continuous on closed interval a comma b and f is differentiable in open interval a comma b with f of a equals to f of b, then there exists at least one point c in open interval a comma b such that f is equals to 0. So there are three conditions on f. First one is f must be continuous on closed interval a comma b. Second is f must be differentiable in open interval a comma b, and third is f of a equals to f of a. If any of conditions fail, then we cannot apply Rolle's theorem. So let us see its geometrical meaning. So this here y equals to f of x. This is a curve between the point A and B. This is point A and this is point B. This point is A comma F and this point is B comma F of B. F of A equals to F of B. No. So this curve is smooth and it is differentiable also. No. So Rolle's theorem and f of a equals to f of b. So what does Rolle's theorem say? If f of a equals to f of b and f is continuous and differentiable, then here we get a point c. Here we are getting a point c at which the tangent line, this is the tangent line which is parallel to x-axis. So f dash c, this is the tangent line which is parallel to x-axis. Now we know if a line is parallel to x-axis, then its slope is 0. Therefore, f dash c equals to 0. So this is the geometrical meaning of Rolle's theorem. Now we will see its generalized version, which is mean value theorem. So now we will see the mean value theorem and prove it. Mean value theorem. Suppose f is continuous. Suppose F is continuous on closed interval comma b, closed interval a comma b, and F is differentiable and F is differentiable a comma b, then there exists at least one point C is open interval comma b such that f is equals to f of b minus f of a upon b minus a. So the statement of mean value theorem is: suppose f is continuous on closed interval a comma b and f is differentiable in open interval a comma b, then there exists at least one point C, that is more than one point are possible in a comma b such that f is equals to f of b minus f of a upon b minus. So in Rolle's theorem, f has three conditions. First one is f must be continuous, second is f must be differentiable, and third is f of a equals to f of b. But in mean value theorem, f has to satisfy only two conditions. First one is f must be continuous in the closed interval a comma b, and second is f must be differentiable in open interval a comma b. Then we get at least one point C in open interval a comma b such that f is equals to f of b minus f of a upon b minus a. Now let us see its geometrical meaning, then we will prove it. So this here y equals to f of x. This is point A. So the coordinate is a comma f of a. And this point is B. So the coordinate is B comma f of B. B comma f of B. So what does it symmetrically represent? So this is the point a comma f of a, and this is the point b comma f of b. Now the curve y equals to f of x is continuous and differentiable because it is smooth and there is no sharp edge. So it is continuous and differentiable. So it says that we will get at least one point C in open area. So here we are getting a point C. Here we are getting a point C where tangent line is parallel to the line joining a comma f of a and b comma f of b. That is so the tangent line is C, this is the point C, is parallel to the line joining a comma f of a and b comma f of b. Now we can write the slope of this is the line a comma AB. So we can write the slope of AB which is same as f dash C. Therefore f dash C equals to slope of AB equals to f of b minus f of a upon b minus a. Now since both are parallel, therefore f dash C equals to, this is f dash C this is equals to f of b minus f of a upon b minus a. That is what mean value theorem says. So this is the geometrical meaning of mean value theorem. Now we will prove this theorem using Rolle's theorem. So proof of mean value theorem. We will use Rolle's theorem to prove mean value theorem. So let us define a function g. Let us define a function g. Function g as g of x equals to f of x minus f of a minus f of b minus f of a upon b minus a into x minus a. We are defining a function g in this way. Now we have to apply Rolle's theorem on g. So g must satisfy three conditions. First one is g should be continuous in closed interval a comma b. Second is g must be differentiable in open interval a comma b. And third one is g of a equals to g of b. Now since f is continuous and differentiable in open interval a comma b, x is continuous and differentiable everywhere, therefore g is continuous and differentiable. Since f is continuous on closed interval a comma b and differentiable in open interval a comma b, therefore g is continuous on closed interval a comma b and differentiable in open interval a comma b. This is our equation 1. So g is continuous on closed interval a comma b and g is differentiable in a comma b. Now we have to check whether g of a equals to g of b or not. So we will put x equals to a in equation 1 and we will put x equals to b in equation 1 and we will check whether g of a equals to g of b or not. So put x equals to a in equation 1, so we will get f of a minus f of a minus f of b minus f of a upon b minus a into a minus a. Now this is 0, therefore this term is 0 and this term cancel out, therefore we get g of a equals to 0. Now put x equals to a in equation 1, so we get g of b equals to f of b minus f of a minus f of b minus f of a upon b minus a into b minus a. Now b minus a cancel out, so here we will get this equals to f of b minus f of a minus f of b plus f of a. So f of b minus f of a cancel out, minus f of a plus f of a cancel out, so this is 0. This implies g of b is 0. So here g of a equals to 0 and here g of b equals to 0. Therefore g of a equals to g of b. Now g is satisfying all the three conditions. First one is g is continuous and closed interval a comma b. Second is g is differentiable in open interval a comma b, and g of a equals to g of b. Therefore we can apply Rolle's theorem on g. Rolle's theorem on G. This means there exists at least one C is open interval will be there and this C equals to 0. Now we will differentiate equation 1 with respect to x and then put x equals to C and equate G dash equals to 0. So we will differentiate equation 1 with respect to x. So we get G dash x equals to this is f dash x. This is constant, so its derivative is 0. Now this is the constant term and here x minus a. So derivative of x minus a is 1. So we will get only this term f of b minus f of a upon b minus a. Now put x equals to c. So we get g dash c equals to, which is 0, equals to f dash c minus f dash c equals to f dash c minus f of b minus f of a upon b minus a. Now since g dash c equals to 0, therefore this term is 0. So we get f dash c equals to f of b minus f of a upon b minus a. So therefore we have proved the mean value theorem. Now we will see an example of mean value theorem. Example 1. If f and g are continuous on 0 to 1 and differentiable in open 0 1, satisfying f of 0 equals to g of 1 equals to 2, g of 0 equals to 0 and f of 1 equals to 6. Then there is some point C in a comma b. Then we have to check which one of the following is correct. So option A is f dash c equals to g dash c. Option B is 2 times f dash c equals to g dash c. Option C is f dash c equals to 3 times g dash c. And option D is f dash c equals to 2 times g dash c. Since we have problem in which f and g are continuous and closing to 0, 1 and differentiable in open to 0, 1. And this satisfying f of 0 equals to g of 1 equals to 2 and g of 0 is 0 and f of 1 is 6. Then we have a point C in open interval boundary and we have to check which one of the following is correct. So let us solve this. So since f and g are continuous on closed interval 0, 1 and differentiable in 0, 1 and here f of 0 equals to 2 and f of 1 is 6. Since f of 1 and f of 0 are not same, so here we cannot apply Rolle's theorem. So we will have to apply Rolle's mean value theorem on f and g. So since f and g are continuous sum 0, 1 and differentiable in open interval 0 to 1. Therefore, we can apply mean value theorem on f and g. So first we will apply mean value theorem on x. So apply mean value theorem MVT on x. So we will get f dash c equals to f of 1 minus f of 0 upon 1 minus 0. Now f of 1 is 6 and f of 0 is 2. So 6 minus 2 upon 1 minus 0, which is 4. This implies f dash c is 4. Now we will apply the mean value theorem of j. Second, apply mean value theorem on g. So what we will get? We will get g dash c equals to g of 1 minus g of 0 upon 1 minus 0. G of 1 is 2 and g of 0 is 0. So we will get 2 minus 0 upon 1 minus 0, which is 2. This implies g dash c equals to 2. Now, clearly f dash c equals to 4 and g dash c equals to 2. Therefore, 2 times g dash c, which is 4, is equal to f dash c. Therefore, f dash c equals to 2 times g dash c. So this is the required answer. So which option is correct? So option D is correct. Option D is correct. Thank you.